Let's focus on our IPv6 global unicast addresses. These are the IPv6 addresses that are routable on the internet. It's what's going to give us our end-to-end IPv6 to IPv6 connectivity amongst devices. So these are assigned by a group called IANA, the Internet Assigned Numbers Authority, who hands them out to regional registries, who then subnet them to hand them out to service providers, who then give them to the various corporations and end user customers, home users throughout the world. So essentially what you're going to have here is from your service provider, you're going to end up with the /48. So we're going to have a /48 here that's given to you from your service provider. And then you have the ability to subnet down to a /64. So you're going to give /64s absolutely everywhere, or you're going to hand out /64s everywhere inside your organization. So that leaves you with 65,536 /64 networks once you do your subnetting here. And then each of those subnets can support 2 to the power of 64 end stations. But let's see what we're dealing with right now when it comes to our global IPv6 unicast addressing. So it says up here that we are in the realm of 2000 /3. Well, what in the world does that mean? Well, what that means is that the first 3 bits right now are going to be consistent and constant. They will not change. That's what the /3 refers to. So let me convert this entire first field of 2000 into binary for you. So we're going to have 0010, then 0000, 0000, and 0000 /3. So that's what it looks like. The first field when we refer to it in binary. So if we must, keep the first 3 bits as 001, then what is the possible range we have for IPv6 addressing right now? It would be 001, 0000000 in the first field, all the way to 001, 111111111 in the first field. Okay, so how does that relate to the rest of the address? Well, the rest of the address could all then be where the double colons are, all zeros, or all the way to the maximum value of all ones in binary. So what is the total value now in hexadecimal that we are signing out for addressing? Well, the top value here really represents what? Well, 2000. And what does our bottom value here represent? Well, if you look closely at that, it's 3FFF. That's it. That's it right now. So we are handing out IPv6 addresses for public consumption right now only in this range of 2000 to 3FFF. And then beyond that, where the double colons are, so all the other fields, because remember there's 8 total fields here, 8 total fields, and I'm only dealing with the first field, so the rest of the 7 fields can go anywhere from 0 all the way up to FFFFFFFFFFF. That's a ton of addresses we're dealing with here. That only represents 1/8 of the entire amount of IPv6 addresses that are available, only 1/8. And we're not going to run out of those anytime soon. Nope, not at all. We're not going to run out of them anytime soon. It's a ton of addresses. So you might end up with something like 2000, 2001, let's say, colon, DB8, colon, A, double colon / 48. So that's what you end up with from your service provider. That's what your provider gives you. So your real address right now is 2001 0DB8 000A. So what that means now is, from your standpoint, when it comes time to subnet this, then you have 2001 :DB8 :DB8 :A, and then in this colon here, you have every possible value from 0000 /64 all the way up to 2001 DB8 A FFFF /64. So there's your 64 or 65,536 possible addresses from here to here, because you get to manipulate all of these. So you can have 0001 or 0000, and then 0001, then 0002, all the way up to 000F. And then you have 0010, then 0011, then 0012, all the way up to 001F. Then you have 0020, then 00. You see, there's a ton of networks in there, 65,536 networks that all can contain 2 to the power 64 addresses. So you might say, when would we need 2 to the power 64 addresses? Well, right now our discussion is solely centered around having voice networks and data networks and video networks, where we're typically going to limit the number of devices to 254. That's it. But where this is going to come in real handy is when we have those Internet of Things. Okay, that's the flashy word of nowadays, Internet of Things, or Internet of Everything. Terms keep changing, but almost everything is going to eventually have an IPv6 address. So what I like to always consider here is sensors. Okay, sensors, bridge sensors is an example. I always like that one. I don't know why. I heard it once and I said, okay, so let's think about San Francisco, prone to earthquakes. What if we had the ability to put sensors throughout the entire city? Very, very delicate sensors that can continuously measure movements in the ground, measure movements of bridges, measure movements of buildings and formations. So that way there we can stay on top of things, right? We know that based on these sensors, the bridge has actually moved 2 millimeters over the last 2 years. Okay, well, compound that over X number of years, that bridge could eventually become a serious hazard, right? Or the building's infrastructure, the foundation could become a serious hazard over time. So we could put tons and tons of sensors, 2 to the power of 64 sensors, in a single subnet, in a single /64 network, because they only collect statistics and then submit them to a central server. It's not like having a computer that's constantly streaming video or constantly users being on the phone on that network. No, these are sensors that gather information, send them to a server. Gather information, send them to a server. So we could have tons and tons and tons of sensors in a single subnet. So that is very, very beneficial to us. So you could put sensors all over an entire city, all communicating to a central server somewhere in the world. Keep track of absolutely everything that's going on. And as a result of that, we could be more proactive with our infrastructures throughout the world. Be more proactive, which is a great thing for the future. So that's just a small example. We won't get into any more philosophical discussions or anything about how we can improve our world, but definitely that's how the addressing is going to work. This is the standard addressing implementation that we're going to utilize. So just a reminder here that we're only dealing right now with this small range, 1/8 of the entire address space right now, and it's barely even been touched. And a lot of organizations are using IPv6 now, and it's put a very tiny dent in the 1/8 of the addressing range. And then you're going to get /48 as a corporation, and then you're going to subnet down to 64s and just deploy them throughout the organization in a hierarchical fashion. And as a home user, when you start using IPv6, your service provider will do all this, and then they can address 65,536 home users with their 1/48. That's a lot of home users that they're going to be able to reach out to, with everybody getting their own /64 network for their homes. And then in your home, that 1/64 network has the ability to address how many devices. So you're not even going to need network address translation in your home, because you'll be able to address 2 to the power of 64 devices based on your 1/64 network that you received.